Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals, More Examples. In this presentation, we will be explaining or solving example problems related to algebraic functions. Let's look at an example. Evaluate this indefinite integral x 2x cubed plus 1 the whole divided by x cubed dx. So we can write this algebraic function as y is equal to integral 2x cubed plus 1 divided by x cubed dx. We want to simplify this expression before we solve this problem. So we're going to take 2x cubed plus 1 divided by x cubed and then simplify it. So since the denominator is the same for the numerator terms, we're going to write the denominator for each one of the terms in the numerator like this: 2x cubed divided by x cubed plus 1 over x cubed. So since we have in the first term x cubed and x cubed, those cancel out, leaving us with just 2 plus 1 over x cubed I can write as x to the power of negative 3. So when we have an exponent in the denominator with a positive power, when we bring it to the numerator, the power becomes a negative power. So as shown here, x to the power of negative 3. So now we can rewrite the given function as y is equal to integral 2 dx plus integral x to the power of negative 3 dx, like that. So now, since 2 is a constant in the first term, so we're going to pull out the 2 outside of the integration process, as shown here. 2 integral dx plus integral x to the power of negative 3 dx. Now we are ready to apply the integration process. We're going to integrate each function separately and then arrive at the answer. So in here, integral dx, so there is integral 1 dx. So there is no x term in here, so therefore we're going to just add an x here, 2x, like that, plus x to the integral x to the power of negative 3 dx. We're going to use the power rule. So let me bring up that power rule one more time. So when we have y is equal to integral x to the power of n dx, so we can, when we use the power rule, we're going to raise the power to the x to the power of n. We're going to add 1 to the power divided by whatever we have in the power. We're going to write that as a denominator as shown here. So x to the power of n, when we integrate that, it converts to x to the power of n plus 1 divided by n plus 1. N can be any integer. So let's go back to our example problem here. So now we are integrating x to the power of negative 3 dx, x to the power of negative 3 dx. So x to the power of negative 3 plus 1 divided by negative 3 plus 1 plus c is a constant of integration. So when we simplify it some more, we have 2x plus x to the power of negative 2, negative 3 plus 1 becomes negative 2, and in the denominator we have negative 3 plus 1, which converts to negative 2 plus c. So when we simplify it some more, 2x plus x to the power of negative 2, when we have a negative exponent in the numerator, we can bring it and then express it as a positive exponent in the denominator. So we can write that as 1 over negative 2 x to the power of positive 2 plus c, like that. Since we have a negative sign in the denominator, we can bring it to the side. Positive divided by negative becomes a negative. So that is equal to 2x minus 1 over 2x to the power of 2 plus c, where c is a constant of integration. So this is the way we want to be able to solve an algebraic function using indefinite integrals. Let's look at another example. Let's say we want to evaluate this example problem. We want to evaluate this indefinite integral x plus 1 times 3x plus 2, 3x minus 2 dx, like that. So here we have a binomial multiplied to a binomial. So we want to be able to expand that and then apply the process of integration. How do we do that? Look at this. X plus 1 times 3x minus 2, we're going to expand it. When we expand that, we're going to multiply the first terms, multiply the second terms, multiply the inner terms, and multiply the outer terms. We're going to use the FOIL method. So x times 3x is 3x squared. X times negative 2 is negative 2x. 1 times 3x is plus 3x. 1 times negative 2 is negative 2. So when we simplify this, we have two like terms. We're going to combine these like terms. The first term is 3x squared. The second and the third term are negative 2 plus 3x is plus 1x, or just x, and then the third term is negative 2. So now we can rewrite the given example problem integral x plus 1 times 3x minus 2 dx as y is equal to integral 3x squared plus x minus 2 dx, like that. Now we can integrate each one of these terms separately as shown here. Integral 3x squared dx plus integral x dx minus integral 2 dx. Since we have some constant terms, we're going to pull out the constant terms outside of the integration process. So, and write it out as follows. 3 integral x squared dx, that's the first term. There is no constant terms in the second term, so we're going to write as integral x dx minus, we have in the third term we have a 2 as a constant, so we're going to pull out 2 as constant, integral dx. So now we're going to apply the process of integration, integrating each function separately, and then applying the integration rules, the basic rules of integration. Where you're going to use the power rule here for the first one. 3 times x squared dx converts to x to the power of 2 plus 1 divided by 2 plus 1. Let me show you that power rule one more time. If we have y is equal to x to the power of n, when we integrate that, we're going to write it out as x to the power of n plus 1. Whatever power we have, we're going to add 1 to that power divided by whatever we have n plus 1 there, we're going to write it in the denominator as shown there. Okay, so let's go back to our example here. 3 times x to the power of 2 plus 1 divided by 2 plus 1 plus integral x dx converts to x to the power of 1 plus 1 divided by 1 plus 1 minus 2 integral dx. So that integral dx converts to just x, like that, plus c is the constant of integration. So let's simplify this some more. So we have 3 times x to the power of 2 plus 1 converts to x to the power of 3. In the denominator, 2 plus 1 converts to 3, plus in the second term, x to the power of 1 plus 1 converts to x to the power of 2. And in the denominator, we have 1 plus 1, which is equal to 2, minus 2x plus c. When we simplify this some more, we have 3 and 3 cancels out, leaving us with x cubed plus x squared over 2 minus 2x plus c, where c is a constant of integration. So this is the way we're going to solve indefinite integration problems involving a product of a binomial, a product of two functions, like that. Okay, so in my next video presentation, we will be solving more example problems related to indefinite integrals.